We are back, everyone. Dr. Jenkins here. So this is going to be video number 2. We began this module by talking about water, its functions, some of its characteristics. Then we talked about electrolytes, particularly potassium and sodium. And then we talked about water and electrolyte balance, right? How water and electrolytes are always moving into and out of the cell. And then overall, how we need to balance and match our fluid intake with our fluid output and all those good things. So here we are, we're going to pick things up and we're going to talk about some general requirements. And then at the end of this, we're going to get into thermoregulation. All right, so now we know where we're at. Let's talk about some general requirements for fluids and electrolytes. Here's our outline. Okay, so I just want to say, these are estimates. It's really hard because everyone is different. I mentioned this in the last video. Sweat rates are really variable. Some people sweat a lot, some people sweat much less. Part of it is genetics, part of it is just who you are, part of it is fitness level, all sorts of things. So it's hard to know exactly. That being said, everybody always wants to have an idea. What are the recommendations? Give me an idea. So I'm being very general. In a general sense, okay, somewhere around, and these are just general, okay, somewhere around 2 liters per day is what an adult female should be ingesting. Somewhere around 2 liters a day, somewhere around 3 liters a day for men. So you can see I've put those in red. I'd like you to have those general ballparks. Of course, there's so many things to factor into it. What if you did an exercise session in the heat? Well, then it's going to be higher than that. But this is a good starting point. A good ballpark starting point. So based on that even, think about you, right? So these are 2-liter bottles. This happens to be a picture of a bottle of seltzer. These are 2 liters. So do you drink 2 liters of water a day if you're a woman? Do you drink approximately 3 liters of water a day if you're an adult male? Just something to think about. Here's what it would look like. So I'm just giving you some ideas. This will not be on the test here, like these water bottles, but sometimes people have a hard time grasping what 2 or 3 liters is. So I've put it in versions of the everyday water bottle that we see, right? So if someone, an adult who expends around 2,000 kilocalories a day, and that really isn't that much. For an adult male, that's probably just how many calories they expend before they even do anything. That's 4 to 6 of these water bottles. What if you actually do some exercise? Well, now we're up to 6 to 8. So I'm not going to ask you this, just trying to put it in terms of something that might make sense to you. Now, of course, those who exercise are going to need more. So you should know both ballpark figures. These were our figures just being you without any exercise, if you sat on the couch all day. Well, of course, they're going to go up pretty significantly if you are an athlete. So these are the ballparks, and they're very broad, folks, because look at the note down below. Sweat rate is something that's extremely variable. So that's why these are, I'm just going to ignore that, I apologize. It's so variable and there's so many factors. So we give a range. And then really it's going to be trial and error to each person. All right. What are some reasons? Well, obviously, or maybe not so obviously, but hopefully it's going to become clear to you. When you exercise, you sweat and you lose some of the water from your blood. So we reduce blood volume. We need to replenish that plasma volume. By replenishing that, we're going to be able to replenish the water needed for chemical reactions for our muscles, for our nervous system. By replenishing enough water and electrolytes, we're going to reduce the risk of heat illness. We're going to keep those electrolytes working as they should to be able to contract muscles and send nerve impulses and regulate fluid balance. Oh my goodness. So many things. How to hydrate properly. Okay, so for an athlete, here we go. For an athlete, you can't just think about hydration during and after your exercise session. You've got to think about hydration all the time, right? It's impossible to get all your hydration in only during your exercise session. So this has to be something that we think about 24 hours a day, 7 days a week. What you hydrate with before is really, really, really important. So the idea is you hyperhydrate before. Hyper means more. So you basically preload. You bring in some fluids extra to have on hand in your body before you exercise. I know this sounds obvious, but you got to actually intentionally do it. Don't wait until you exercise. Be thinking about your hydration before. Even if you just set a goal, I'm going to drink 4 of those water bottles in the hour and a half leading up to my exercise session. It does work, right? Hyperhydration before exercise. We're talking about pre-exercise. The research tells us it works. So I just have this screen here to basically tell you that the evidence from the research tells us that bringing in more fluid balance before exercise helps you perform better, thermoregulate better, all those things during your exercise session. Here are some examples of what some of the recommendations are, but again, everyone is so different. So these are only guidelines. You can see 2 to 3 hours before, 17 to 20 ounces, 10 to 20 minutes before, 7 to 10 ounces. If you look at those numbers, that really isn't that much. I might argue you need a little bit more than that even, but again, it depends on your size. So these recommendations are not based on body weight. So a person who has more body weight is going to need more fluid. But it just gives you some ballparks, okay? You don't have to know these guidelines specifically in this slide. Just throwing them out there. I've already said this before in the first video. Just going to make sure I say it again. Thirst is not a good indicator. The old trope is by the time you're thirsty, you're already in a state of slight dehydration. The research now is kind of like, well, maybe that's true, maybe not. But no matter, we still can agree, we still know that thirst alone is not a good indicator. Thirst helps us. Your thirst is a signal from your hypothalamus saying your body needs water. So it's an important signal. So that thirst sense helps us, but it's not what we need to rely on alone. We've got to be thinking about hydration even when we're not thirsty, just to make sure we're constantly bringing in enough fluid. So before, we are talking about pre-exercise. Water is best. And look, I put everything really important in red because I'm there for you. You do not want to drink Gatorade or something sweet with the carbohydrates, the sugars, before. It will, if you drink this before, it will increase your blood sugar quickly because Gatorade is full of simple sugars, high in glycemic index. So it will increase your blood sugar quickly, followed by a pretty quick crash. And that crash is likely to happen before or at the very beginning of your exercise session. And then you're trying to exercise more, but now you got this crash in energy and it's going to make it harder for you. Some people do, caffeine. We'll talk about caffeine later in this semester. Caffeine has shown some benefits to certain athletes to help with focus or a little bit of energy. So maybe some coffee or tea with caffeine. For example, I know of marathon runners that will drink a small cup of coffee, a couple ounces of coffee before their race for the caffeine benefits. But you can see that word there, moderation. It's not a big Dunkin' Donuts or Starbucks latte. But the key remains I just took some water myself. Look at me hydrating. But the key remains, water is best before. Here are some observations. I'm not going to ask you this, but if you go into an exercise session dehydrated, even mildly, it absolutely will impair performance. Okay, that's the proof right there, some proof. Okay, I've already said this, but we just need to make sure we say it and it's in red so you have clarity that you need to know it. The amount of fluid loss and the sweat rate vary. So these are two different things. We're talking about the amount that someone sweats and the rate at which they sweat. Someone may sweat a lot, but their sweat rate is lower, so it takes them a longer time to sweat out all that fluid. Other people sweat a lot and very quickly, so there's two things to consider there. Just know that it varies a lot. Okay, here are some examples of the sweat loss for different athletes this year. I'm not going to ask you these numbers, but the Jake and Droop text that we reference gives us some numbers that have come from the world of sports, so this is real data. Okay. Something, I'll just point this out. I've done triathlons myself, done 4 Ironmans, all that stuff. And now I've kind of transitioned to being a full-time cyclist. And it's interesting, in the cycling world, people may not think that they sweat as much because you're moving faster. Like when you're running, you might be more likely to feel the sweat on you. But when you're cycling and you're going faster in the breeze, sometimes you don't realize you're sweating, but you absolutely are. Look at this sweat loss, right? Of course, it's hotter degree here than some of the others, but just an interesting little point. Here are some marathon runners in finishing time, and the sweat rate is all over the map, right? All over the map, so variable. That's all that I want to show there. Okay, now we're going to switch to talking about fluid intake during exercise. So we talked about the importance of bringing in fluids before exercise. Water is best. Now let's talk about fluid intake during exercise. Well, what are the purposes? Well, we need to bring in water during exercise and fluid during to replace the water that we lost. If you sweat, you're losing water. We need to replace it. We also tend to lose electrolytes, much more sodium than potassium. You don't need to know the specific numbers, but these are the reasons why it's important to rehydrate during certain bouts of exercise. There are so many guidelines, everyone. I'm going to give you the guidelines for fluid intake during exercise from the American College of Sports Medicine. These are general. They don't take into consideration age, gender, fitness level, the individual variation. So we cannot take these as the concrete truth. Rather, they are just some general guidelines to give us a ballpark, understanding that everyone is a little different. Overall, you want to match your fluid consumption with what you lose during exercise. One way that you can do that, and one way that athletes do this, is they weigh themselves before an exercise session and they weigh themselves after. You might lose a little weight, but you should not lose more than 2% of your body weight. If you do, it's indicating that you lost more fluid than you were able to bring in, and it could have been to dangerous levels. So, what are the general guidelines? Again, people, very general. The general guidelines, 7 to 10 ounces of fluid every 10 to 20 minutes. We're all different. I know this isn't going to be right for everybody, but it just gives us a ballpark. What I like about this is it gives us a ballpark, as I just said. And what I also like about it is that it gives you the idea that you want to be hydrating in relatively smaller amounts over and over and over again. So it's not beneficial to wait until halftime and then just down 2 gallons. That would be a lot. Get down a whole bunch of fluid. Instead, it's better to bring in smaller amounts repeatedly over time. Excuse me. During exercise, water still remains our first priority. We are talking about during exercise, right? Water is still our priority. We consider a sports drink only, only, are you listening? Only if the exercise is greater than 45 to 60 minutes in continuous duration. What does this tell us, folks? Let's talk about a 5K, 3.2 mile run. What's a good 5K time? You think about maybe what your 5K time is. I don't want to brag or anything, but back in my heyday, my best 5K time was 19 minutes and 16 seconds. Maybe your 5K time is 20 minutes, 25 minutes, 30 minutes, 35 minutes. You know what? All those times I just listed are less than 45 to 60 minutes. Does someone need to bring in Gatorade during a 5K? Absolutely not. Absolutely not. So what are the reasons? Well, up until 45 to 60 minutes, you have enough sugar and electrolytes stored. Period. If I'm doing a 20-minute run, I've got enough sugar stored in my muscle, in my liver. It's right there. If I'm doing a 30-minute run, I have enough electrolytes floating around. So if you bring in a sports drink for a short-term exercise, it's just extra sugar. You might as well just eat a candy bar. You're just bringing in added sugar that you don't need because you have enough in storage. However, if I'm exercising for 60 minutes continuously, this could be a bike ride that's an hour and a half in duration. This could be a basketball game where it's short spurts of sprinting followed by jogging. And even though there's some breaks in there, it's pretty much continuous. For how long is a half? It depends on if it's high school or college or pro, right? But overall, the game is going to be longer than 45 to 60 minutes. So only then would you consider a sports drink. Okay, the best temperature to drink these fluids is a moderate temperature. So what I'm saying is really cold water is actually not best for absorption. I don't know about you, but as an athlete myself, I experience this to be true. I don't want it to be too cold. It's almost like a little shock to the system when your core temperature is elevated a bit from the exercise. And research has shown this to be true. I'm not saying it's terrible, but if you're really looking for maximal absorption of that fluid to best hydrate, a moderately cold, not really cold, beverage is best. Remember, a sports drink only needed in a continuous exercise lasting longer than 45 to 60 minutes. It will replenish fuel. It will replenish electrolytes. And only at this time is it a consideration because up until 45 minutes, we have enough stored glucose and stored electrolytes. From the carbohydrate chapter, we should be ingesting about 70 grams of carbohydrate per hour. Shouldn't be too much. This is our guideline, but it's also a little bit variable. Some people have guts that can absorb a little bit less only. So everything here is a little bit trial and error. But this gives us a ballpark. Remember, you need to know everything that's in red. All right. There are specific recommendations for the electrolytes. This gives you the recommendations for some of our positively charged electrolytes or cations. You don't need to know the specific numbers. We focused on sodium, potassium. And all I want to remind you of is we always need to bring in a higher ratio of sodium. So even though, for example, Gatorade Gatorade, Powerade, Accelerate, Endurox, they all have sodium and potassium. But if you look at the label, they're going to have more sodium because you lose more sodium in your sweat. You lose less potassium. Therefore, we don't need to bring in as much potassium. So we need to replenish with both potassium and sodium if the exercise is continuous for longer than 45 to 60 minutes. But the ratio should be more sodium and less potassium. So, fluid intake during exercise. Is Gatorade is it a proper sports drink? You know, sometimes, hopefully I've taught you to be skeptical. Hopefully. So, if I'm doing my job, hopefully your initial question would be like, wait a minute, Gatorade is made by the Coca-Cola company. Do they really have my best interest at mind, or do they just want me to buy it? So is it really properly put together? That is the correct skeptical approach, ladies and gentlemen. But here is an instance where, you know what? Gatorade actually does a pretty good job. They do a pretty good job. Do you know where Gatorade came from, by the way? Back in the 60s at the University of Florida in Gainesville, Florida. You know the Florida Gators. Come on now. One of the athletic trainers and one of the helper dudes realized that these football players were not performing to their best. He's like, maybe I could concoct a beverage with some sugar in it and electrolytes. And that was the beginning of Gatorade, hence the term Gatorade, because they came from the University of Florida. All right. So overall, Gatorade is a good sports drink. It is the appropriate osmolarity. We talked about this in the digestive chapter. See how it all comes together, folks? The appropriate Gatorade during exercise is between 200 and 400 milliosmoles per liter. Boom, Gatorade looks good. The concentration of the sugar should be somewhere between 6 and 8%. We can't see that on this chart, but we know that to be true. Gatorade has a concentration of overall sugar that does fit between 6 to 8%. Does it have an appropriate potassium to sodium ratio? Or we could say sodium-potassium ratio. Per 8 ounces, Gatorade has 110 milligrams of sodium, so it's got a lot of sodium, and 30 milligrams of potassium. So a lot of sodium, less potassium, that is the appropriate ratio. Excellent. As a side note, some people like to dilute their Gatorade. I am one of them. When I put Gatorade or Accelerate or whatever kind of sports drink I'm drinking for a bike ride, let's say, or even if I was doing it during my running days for a marathon, I prefer to dilute it. It's a little sweet for me, so I would probably dilute it 50-50, Gatorade with water. Personal preference. No matter what you do, you would just need to make sure that even if you dilute it, you may have to bring in more to get in the enough sugars and electrolytes. Other considerations during activity. You can read through these, right? They're not in red, but kind of common sense, but things to think about. Take regular breaks. Don't wait. Start consumption early. This is a mistake people make. They're playing a basketball game, and maybe the whole first quarter, they don't drink anything because they're feeling fine, right? You can't do that, folks. Even just take little sips. And in some instances, you have to train your gut. If you're not used to it, it's going to take your body some time to get used to it. So you may have to train your gut a little bit. So even if you start with really, really small sips towards the beginning or the middle, then that's where you got to start. Also, I hope you know this, practice what you drink and eat before game day. In the endurance world, this is a rule everyone knows about, but it does apply to all sports. Don't wait until your first game to be like, oh, maybe I'll try that. Try your beverages and your foods before, during, and after. Try it beforehand so you know if it works. All right, so I'm giving you some practical applications You don't need to know these, but again, our recommendations were ballpark figures, but I just gave some examples just to give you a place to start. So here's what somebody would need to drink in a football practice potentially versus a marathon. So just some applications as an idea. Okay, so we talked about hydration before exercise. We talked about hydration during exercise. Now, what about hydration after exercise? So, right after exercise, we've got to replenish water and electrolytes because we just finished losing a lot of them. The hydration, folks, doesn't stop the minute you cross the finish line. You have to continue, right? You were basically just trying to keep up, and you probably operated at a little bit of a deficit during. So after, we've got to make sure that we replenish everything, top off our storage of water, electrolytes, and sugar. You don't need to know the specific numbers. The goals for post-exercise hydration: replace what you lost. Here are some amounts. You can see that the rehydration should be complete within 6 hours. You might think that's a lot of time, and I suppose in some sense it is. But if you lost a lot of fluid, you're going to need that time. Don't wait until 3 hours after exercise to get started. Start rehydrating as quickly as possible. Smaller bits over time until you can get back to where you need to be. So, what are some good options after? Well, folks, water is always good. Here, we might do a sports drink immediately after. I'm not talking about a sports drink an hour and a half after. I'm talking about immediately, within the first 15 minutes. Like, that's how immediate I'm talking about. Chocolate milk is a good post-exercise beverage. Some people like juices. Just got to be careful with all the simple sugar in those. If rapid rehydration is needed, then the sports drink would be our priority, right? My best recommendation would be some water, but also some sports drink or chocolate milk. Here are some of the guidelines. You should begin to do your post-exercise rehydration as quickly as possible. Should be complete within 6 hours. And it's best to drink smaller quantities more often. Here is a summary of what we talked about. Our daily needs, ballpark, our pre-exercise needs, during exercise, and post-exercise. Okay, we're going to keep trucking along, everybody. Here we go. So, the last section of this chapter is all about thermoregulation. Here we go. So, to begin this discussion, I like talking about something called the Badwater Ultramarathon. You think I'm crazy for doing the Ironman a couple times? Let's talk about doing an ultra marathon. Yeah, running 135 miles in the desert of California in July. Actually, it's kind of stupid. This is an ultimate test of our body's ability to thermoregulate. Can you imagine? They'll have a little support team, get your friends in a van behind you. Crazy. Ultimate test for thermoregulation. These are the older records. I'm sure that they're better by now. But can you imagine running 135 miles in the desert? Look at the average temps. And not only that, there's a big elevation change because the end is in Mount Whitney, California. You're starting below sea level and then you're climbing all the way to 8,000 feet, above 8,000 feet. Okay, anyway. Just like we talked about balance with fluid, right? We said we need to balance whatever our fluid loss is, how much we sweat, we need to equal that with our fluid intake. If it's a hotter day and I lose more fluid, I got to bring in more fluid. Well, it's the same idea with heat. If I take on a lot of heat, so in other words, if I exercise, I'm producing body heat. What if I exercise in the desert? I'm bringing in even more heat. So you need to balance whatever heat you're producing in your body. Maybe another word here to help you understand would be heat production, heat gained or produced. Then I got to balance the heat loss. How are we going to get rid of heat? Sweating and some other means. The goal is to balance. If I produce more heat, I got to find ways to get rid of more heat. Okay, so just like we did in the fluid chapter, fluid portion, we talked about what are ways in which we lose fluid? What are ways in which we bring in fluid? Well, here we go. We're going to talk about ways that we gain fluid or produce, heat. We're first going to talk about how we produce heat. Then we'll talk about ways for us to get rid of heat. So how do we produce heat? Heat gain or heat produced? We produce heat in our body by exercise. When you exercise, your muscles release heat as a byproduct. We can produce heat in our body from the environment. If it's hotter out, our body temperature is going to go higher. And one that you may not think about is just your basal metabolic rate. This is your organs just doing their normal functioning. Yeah, even if you were just sitting on the couch, which I know you would never do, haha. But even just sitting on the couch, your liver is still working. Your heart is still pumping. Your lungs are still working. Your kidneys are still working. On and on and on. Well, all that activity just to keep your organs going, it produces some heat. We do produce some heat through hormone production. We do produce some heat by digesting food. But you only need to know what I have here in red. So, heat gain. We know that we produce heat during muscular activity or exercise. Okay, that's just a repeat. We can see our normal core temperature when we are just sitting down or sedentary. And then what happens to our core temperature when we exercise? So we expect a little, what is that, about plus 2 degrees Celsius? We expect a little increase in core temperature. And our body will tend to send that heat that's being produced at our muscles into the core. Okay, so even when we are properly thermoregulating, our core temperature will go up a little bit when we're exercising. But we have to have those thermoregulatory mechanisms to prevent the core temperature from going even higher. We don't want to go higher than that 40 number. That's bad. How much is too much? A small increase in core temperature is normal. What did I say? A small temperature increase, like 2 degrees Celsius. You should know that. A small increase in core temp during exercise is normal. A large elevation, not good. Once we get to that 4 or 5 degrees in increased core temp, then we start to see some dysfunction. You should have an idea about these numbers. Okay, so we talked about ways in which our body produces heat. Our body produces heat through exercise, through dealing with the environment, and through our basal metabolic activities. Just our organs doing their thing naturally produces some heat. Those are ways in which we produce heat. We have only 4 ways to get rid of that heat. Here they are. How do we balance out that heat gain? We've got 4 ways to get rid of heat. Make sure you review all of these. Radiation is basically the transfer of heat through electromagnetic waves. That's kind of a weird thing to say, but that's kind of the best definition I can think of how to put it simply. Conduction and convection. Conduction is to transfer heat through direct contact. You know, if you sit in a chair that someone else just sat in, doesn't that chair feel warm? Well, that's conduction. Convection is transfer of heat over air or liquid. Using a fan can transfer air temperature or liquid. You can cool or warm yourself by pouring liquid of certain temperatures over you. And then, of course, our ability to release heat through evaporation. When we sweat and that water goes to the surface of our skin, those water droplets on your skin will evaporate into the air, thus having a cooling effect. These are all in red, so be able to answer a multiple choice question about it. Here's just a basic schematic to show everything at play, right? So I'm not going to dwell on this, but I'm just saying we take on heat. We take on heat because our muscles produce it. We take on heat because it's hot out, right? And then we've got to find ways to release the heat. We release heat by sweating. We release heat by the movement of air. We release heat through radiation. So it's a balance, right? At the same time as we're taking on heat, we're trying to get rid of it. Okay, important points to know. We're going to go in green. At rest. So we had those 4 ways in which we can get rid of heat, right? Remember? 4 ways we can get rid of heat. Well, we utilize all 4. At rest, we tend to utilize more of the radiation. I think about R and R, rest, radiation. At rest, we utilize more of the radiation way for heat loss. During exercise, we're still trying to lose heat through radiation and conduction and convection. But during exercise, we're going to rely mostly on evaporation, sweating. So even though we rely on all 4, at rest, we're relying more on radiation. During exercise, we're relying more on evaporation to get rid of heat. Okay. So how do we thermoregulate in a hot environment? Right? So what are the ways in which we can best keep our core temperature at a reasonable temperature when it's really hot? Well, you want to prehydrate. You want to maintain your hydration during and after. You can choose certain clothing. So this picture of the dude from the Badwater Ultramarathon, he's wearing lightweight, loose-fitting clothing. Oops, sorry about that. You don't want to use cotton. Cotton is just going to absorb your sweat, and then it's just going to hang on you. You want to use something that's a wicking material. You might wonder why he's got long sleeves on. It's to protect from the sun. But you can see that his shirt is very light. Now, it's not just about temperature. It's also about humidity. So make sure you can define humidity. Humidity is basically the moisture in the air. Presence of water vapor. Another way of saying that is the moisture in the air. I got these pictures on the side. If we think about Las Vegas versus Albany, which is going to have a higher humidity? Albany, right? Las Vegas has a very dry heat. So it can be 100 degrees and it's going to feel hot, but it's not going to feel as oppressive as 85, 90 degrees in Albany with the humidity. So when there is more humidity, when there's more moisture in the air, it is more difficult to evaporate. I think you know this probably. You know, on a hot summer day sometimes, especially when you're not used to it yet, June, that moisture in the air, it's just so oppressive. It kind of feels like a wet blanket already over you. So in low humidity conditions, we are able to send a lot of moisture to the surface of the skin, and then we can evaporate a lot of that moisture off the skin into the air. But in high humidity conditions, this process is harder. Think about it. When there's already moisture in the air, we have reduced the concentration gradient. In order to sweat and convert that moisture on our skin into water vapor for the cooling effect, in order to sweat, we've got to have a gradient where there's more water on our skin and less water in the air. Let me say that again. In order for us to be able to sweat, convert that water on our skin surface into moisture in the air, in order to do that, we need a gradient. We need more water on the skin surface and less water in the air. That's how it works under normal conditions. But when there's high humidity, there's already some moisture in the air. So we have decreased that gradient. Now we have moisture on the skin surface, but we also have moisture in the air. So we've reduced the gradient, and sometimes there's no gradient. So your body will send water to the surface of your skin, but your body won't be able to evaporate it because there's too much moisture in the air already. Sweating can stop if the moisture in the air becomes greater than the moisture on the skin surface. Okay, we're almost done here, coming down the home stretch here. What about cold environments? In cold environments, there is less heat loss, right? It's cold out, so you're not going to be sweating as much. So there's less heat loss, there's less sweat. It's easier maybe to overhydrate. Certainly it's less problematic. It's more about just keeping your extremities warm because the body will tend to pool blood to the core, making your extremities more at risk for a decrease in blood flow. So heat is really when it can become a problem. I talked about heat illness earlier in our first video. So it's absolutely something to be taken seriously. What are some of the recommendations in the cold? Maintain activity, multiple layers. You know, these NFL players are so tough. They got these big heaters. I'm sure your high school teams don't have that, right? Okay, couple of last slides here. Acclimatization. It is possible to adapt over time, right? If you are used to a hotter environment, your body is going to be better able to thermoregulate. We can acclimatize to heat and cold. Really, we're talking about heat. You really can't acclimatize to cold. You can only just put on more layers. But with heat, we certainly can. Make sure you look at 2 physiological adaptations when we have acclimatized. You sweat sooner and you sweat more. That's a good thing. That means you're more effective at your sweating. Some factors that affect this. Children, I mentioned this in the first video. My friends, children have less sweat glands, less surface area, a higher core temperature to begin with. You have to be a little bit You have to be cognizant of that. You can't push your little Pop Warner football kids the same as you can push your college team. The physiology of the kids is not as good at evaporating. There's a difference in gender. Males produce more sweat. They have more surface area, and in many ways can get rid of heat better. So some people might say, oh, the female team, they're being a bunch of babies. Well, folks, there is some physiological differences. So men, in many instances, do produce more sweat, and they can be better. Not always. As I said earlier, women tend to utilize different mechanisms more. Men tend to rely more on sweat, but they're more wasteful sweaters. Women tend to rely some on sweat, they're more efficient, but they also rely more on cardiovascular shifts in fluid. Overall, men and women pretty much have the same ability to thermoregulate, but there are certain factors to consider. Men usually have a greater surface area, more fluid volume, so in some instances they may be able to better thermoregulate. Your body fat, I mentioned this before also. Look at this lineman dude, right? If you have more body fat, that adds as an insulation. So it makes it more difficult to get the sweat to the surface of the skin. This is why a lot of the people who have unfortunately died from heat stroke in the athletic world are the bigger linemen. All right, I am going to go back because I do want to answer one question before I finish up. People usually ask me, how long does it take to acclimatize? The best practice I would say 10 to 14 days. So, if there's a competition at elevation, if there's a competition in a warmer or more humid environment, it's best if you can go there 10 to 14 days earlier. That's not always possible, though. You can start to see some adaptations within 2 to 3 days. So it's obviously not going to be great. But, we think about teams that are traveling or money or people have to work, go to school. You can't always just skip town 2 weeks early to go somewhere. So we can start to see some acclimatization maybe within 2 days or so. That's better than nothing. But to best acclimatize, the longer you are there, the better. All right, folks, long chapter. I'm here if you have questions. Good job.